Hello, lovely people. Today I'm going to be making an experiment that I have really low hopes for succeeding in measuring anything, but I'm going to do it anyway. Today we'll be measuring and trying to find out if there's any differences between different RCAs. Every time we talk about cables, wires, or anything online, there's going to be always a debate that everybody's going to say that more expensive stuff sounds better because of, I don't know what kind of reasons. So today I'm going to try to measure something. Again, I have no idea if I will succeed anything. However, I'm going to run through how I'm going to measure, what I'm going to measure, and why I will be measuring that. If you're expecting in this video for me to plug loads of RCAs into amplifiers and listen to them or give my impressions or make a demo videos of a song, that is not gonna happen. If you're expecting that, you can stop the video and go look into some audiophile channels that they do that kind of stuff. I'm concentrated and my focus is on objective measurements. I know there is a lot of tests already done online that people measure the cables and they cannot find any differences, so that's why I have very little hopes that I expect that I'm not gonna see any differences. But let's try it. I think it's gonna be the same like we had a situation with damping factor, where I did all the testing and everything, and at the end of the day, there was just nothing, nada. So we'll see. So online, as I mentioned, there's always gonna be a debate of which cable sounds best. Now, how we describe sound in objective measurements, that's gonna be mainly the frequency response and the distortion, and that's exactly what we're gonna be testing. So I do have this thing, which is called Quantasylum QA403 audio analyzer. This works on a level of audio precision. It's super clean. It has a separate PCB for the power supply and all the inputs outputs, and with this I can measure DSPs. It's a super clean piece of equipment, and I will be measuring it on loopback. That means that the audio interface, it's gonna measure itself. I'm gonna feed output of the interface into the input, and it's gonna measure whatever passes through the cable. Now when you're using this thing and you have a single-ended input, which is this, because this can be used on differential inputs, you need to use a shorting plug, and you can see I have a 75 ohm shorting plug on one of the inputs. That's why it's there. And for this, I just have at the moment plugged in just a cheapo, probably CCA cable that has absolutely no protection, no nothing. There's no shielding. It's just two wires running parallel next to each other. I was thinking what kind of connection to use, because a lot of people say that the connections themselves, the actual RCA plugs or whatever plug you're using, introduces a lot of distortion and adds extra resistance. So I decided not to use any connections at all. These are typical BNC plugs, you can see, and what I'm going to be doing, I'm going to put the positive one inside there, and the negative I'm gonna clamp with this peg. Now I decided to use plastic pegs so that if it's gonna be something metal, it's gonna be acting as an antenna potentially. It's still grounded, but it still might be, so I'm using something plastic just to have a firm connection to the ground. And you can see right there, positive in there, negative in there, and I'm gonna do exactly the same with all the cables that I will be testing. Now in regards to the cables, what do we have here? I bought these online, and there's a shop, I don't remember how it's called because I wanted to do this test probably like a year ago, and that shop allows you to buy like 30 centimeter samples, which is 1 foot long, and these samples are cheap because it's short length. So for reference, I will be using this cable, which it is from AliExpress, but it is a BNC to BNC, like a jumper cable, that it is shielded. It has some, at least it claims that it has some standards to it, I'm not sure. So this is going to be my reference cable that's gonna go from that to that. Then I will be testing this, just as I mentioned, just a simple speaker wire, again from AliExpress. Probably CCA is the worst that you can possibly find. I do have these, which are, I have no idea how old are they, because you can see in this, that's the only shield that it has. It's literally just a few wires. So basically this is probably the worst RCA cable that you can find. Very thin, probably oxidized as well. So I'm just gonna chop the length according to this, and I'm gonna be measuring this one. And now for all of these, there's very different cables for very different prices. Most expensive one is going to be this one, which is, it's very hard to see with the glare, but this is Van Damme silver series transparent, ultra pure silver plated OFC. So this runs, oh man, I don't remember the price, but it's expensive. I think this one cost me like close to £10 or something. So this is should be one of the best that I have. Again, I'm not gonna have any audiophile grade cables that cost like thousands of pounds or dollars. That's not gonna happen. And probably the criticism it could be that you might measure something with more expensive cables, but what we'll be measuring is the degradation of signal, because the passive cable cannot improve signal. So as long as the signal is as reference or like all the same, we know that nothing degrades the signal and you cannot improve it. So what else do we have? This is something Mogami. Not sure what the model is. This is another Mogami. Low something microphonics cable. I have quite a few Sommer cables. So this is one Sommer, whatever. There's another Sommer. Probably different model. There's another Sommer. This is very, very flexible. Very cool. This is another Mogami, patent pending low noise wire. This is another Sommer, which is, I don't know if it's just a jacket different or the cable actually different. I tried to choose different models. What's this? Fox 1 mono. That's all that I have on the wire. Then this one is Belden. So this is a video cable, but a lot of people use it for RCAs as well. Belden 1694A. And I do have some microphone cable from Thomann something. This is like 2-wire cable. I'm going to be using it as an RCA as well, just because I have it lying around. And I have this Van Damme Pro XKA instrument cable. This is my favorite one, silver-plated OFC, just because it's super, super flexible, and I really, really like it. I use it in all my installs previously because it's very flexible. So all of these cables, they are different in basically every aspect. Let me try to show you like this. See? So all the cables are very different. They have different conductors, different size conductors, different shields, different size shields, different jackets, materials. Basically, all of them are different and not a single one is similar to the other one. If I will measure any differences, if I'm going to see anything that something stands out, then at the end of the video, I will point out which cable it was. So now let's talk about what are we measuring, what we will be measuring. This Quantasylum can give 8 volts, it can take up to whatever volts. I will be measuring at 1 volt RMS output because I want to measure a low, kind of lowish signal that could take a lot of noise in, because one of the things that I will be testing is the noise rejection from the actual shield, the braiding, because all of these are coax cables and everything is braided and shielded. So this thing, it can run up to 192K. So we'll be measuring the frequency response up to 98 kilohertz, which is going to be much higher than the audible range, but it's just to see if there's going to be any roll off. Now, cables themselves, they have basically 3 main properties, which is the resistance of the cable, the inductance, and the impedance. Inductance and impedance will affect the frequency response in a way that it can roll off at the top end or it can roll off at the bottom end. Now, the resistance of the cable is going to be the level, because basically the more resistance it has, the less level it has. So if I'm going to be measuring at the same output voltage from this thing, if I'm going to be seeing even 0.01 dB drop in level, with this, I know that one is going to have slightly higher resistance than the other. Now, another criticism, it could be that these lengths are going to be too short to see any of the differences. Now, I am a car audio guy because probably there's going to be a lot of people from home audio or like PA world watching this video, and they will be using these cables in 10s or even 100-meter lengths. In car audio, we use very short lengths from the DSP to the amplifier. So like 30 centimeters, 1 foot. I don't want to say it's an average size, but the longest RCA cable that I had in my install from the DSP to the amplifier was probably like 3 feet, which is like 1 meter long. So it might not be the actual representative of the normal size of the cable, but again, these were the samples that I bought and I didn't want to spend any more money on it. So let me show you an example of this cable, how I'm going to be measuring it. If I'm going to go to RTA and I'm going to click on Analyzer, This is gonna be my floor noise. When it settles down, I can see minus 160. So this is extremely, extremely low. And I'm gonna capture this measurement and I'm gonna have it as a reference for that specific particular cable. Then at the same time, I'm gonna play a sine tone of this level, which gives me about 1 volt. But most importantly, because with this cable, it gives me an even level at minus 18 dBFS, and then I can see everything is equal, and then it starts to drop off at like higher frequencies. We will see if this is caused by the actual cable or is just the audio interface it is when we're going to compare all the other ones. And I will be able to measure a drop at a certain frequency. So probably we're going to take like 20 kilohertz, and then we will see how much the signal drops at 20 kilohertz. So for this specific example, it's going to be, if I'm going to put the mouse cursor here, is going to be 0.06 decibels. Then I decided to introduce some noise because, as I mentioned, shielded cables should reject noise. So I have this, which is an LED bulb. If I'm gonna turn it on, there we go. It is running on the worst power supply that I have that is super noisy, switching power supply, 14 volts. It is running, and if I'm gonna take this LED and I'm gonna put it on top of the cable just like that, super scientific, and I'm gonna go to RTA, measure the same noise, you can see that I have all of these spikes that are coming from the actual LED. So by capturing this, I will have the floor noise with the actual noise, and then we'll be able to compare how this noise is prominent in different cables as well. And you can see this is the noise, and then I'm gonna capture just a simple 1 kilohertz tone. We will see the harmonics, but I don't know if we're going to see anything. And if I'm going to go to frequency response and distortion, we can see the actual distortion, which in this case is 0.0002%. And we will see if that distortion is different with different cables. So now what I'm going to do, I'm going to take my time, I'm going to measure all of these cables, and then we will see if there's going to be any differences between them. What I want you to do now is stop the video and in the comments below comment, what do you think? Will we see any differences? Or will we not see any differences at all? Oh, and if anybody wondering why I'm doing this test here in the corner, I'm basically trying to get away from any other possible sources of noise, because in the kitchen we have a fridge, we have a light LED and everything, and this is very quiet corner where the only thing I have is that socket and absolutely nothing around. So I know that the only noise that's going to be introduced is going to be by this thing. And we're going to start simple with the frequency response. So this is a frequency response of all the 15 cables that I have, all of the RCAs, plus the BNC to BNC, and plus that red and black wire. And the frequency response is the same. There's absolutely no difference. Okay, so this is 5 dB scale. Let's increase the scale as much. So this is the scale of 0.1 dB. So at 20K, the frequency response is dropping by 0.05 dB. And yeah, this looks a lot, but in reality is just like here we have 1 dB drop up to 50 kilohertz. So there's nothing. Let's try to zoom in as much as we possibly can to see. There we go. So this is a scale basically as much as REW lets us to zoom in. And the difference between the highest level, which is something like 9848, and the lowest level, which is 9835, and the difference between the highest and the lowest is 0.0013 decibels. So this difference is, in the beginning, I thought it might have to do something with the thickness of the copper that's inside the cable, but to be honest, I think that this difference is just because of the quality of the connection between the audio interface and the actual cable. And it just so happens that the thicker cables make a better connection by having a more surface area that actually makes the connections, whereas the thinner cables, they have less surface area for connection. And the best one here on the top you can see is the BNC to BNC efficiency because it's a proper connector that has the most surface area. So definitely the frequency response, there's absolutely no difference between any of these cables. Now, I did measure the floor noise of all of them, but to be honest, the floor noise itself, again, there's absolutely no difference between these. All of them are exactly the same. Now, if we have a look at the 1 kilohertz tone, which is this one, again, I went through all of them and I was looking at the spectrum from 20 all the way up to 98 kilohertz. We have these harmonics, and the numbers that we're looking at is the signal to noise ratio and THD plus noise. And to be honest, the difference is, like THD plus noise, the difference is in 0.0001. So sometimes it's 7, sometimes it's 8, sometimes it's 9. So there's literally no difference. The difference in signal to noise ratio is here is 100.3, 100.4, 100.2, so 0.1 dB in signal to noise ratio. So all of these discrepancies are definitely not the differences between the cables, but just literally the error in measurement. Now, when we're doing the sweep here, as I mentioned, we can have a look at the distortion, which is this one. And difference between distortions, this is extremely zoomed in scale. Typically, we would use a scale something like this. DSPs would be here, whereas 0.001. Amplifiers are something like below 0.01, somewhere there. And this is the THD of this. So again, let's zoom in extremely. This is 100%, just to see if we can spot any differences. So this is a scale you can see from 0.001 and much lower. And the differences, again, there's no differences. So this is THD. We can have a look at the same time at second harmonic. Exactly the same. We do have some discrepancies here, but again, this is just literally, the level is so low that it's error of measurement. But you can see everything is exactly the same all the way up to the 9th harmonic. So there's absolutely no differences. Now, the thing that where I did spot a difference is the noise introduced by the LED. So you can see this is the noise, and it's mainly in the audible range. That's why I chose this specific LED just to introduce noise here and not something at like 50 kilohertz, 70 kilohertz, because the switching noise of the power supply, even if it's gonna go past the shielding, it's not gonna affect the sounds at all. However, when we have some noise introduced in the audible range, then it could potentially affect something. However, I want to point out the scale. So this scale in dBFS, and this level is minus 160. And these noise spikes are at minus 143. Now, for reference, normal amplifiers will have this noise level at about 120, 130. So basically, all this noise that is being introduced is way below even the cleanest amplifier's floor noise. DSPs are going to be a bit cleaner, maybe somewhere here like 140, but like literally nothing is reaching 160. And the difference between these cables, there's literally error of measurement. All of them look exactly the same. The only real difference that I saw, even with that very, very bad quality cable, I called it old and where we have literally just a few strands of copper. Yes, we do have a little bit more noise peeking through it, but again, we're talking about a difference between 143 and 139, which is 4 decibels difference. But again, as I mentioned, the biggest difference is this simple speaker cable, which has absolutely no shielding. This one picks up noise everywhere. You see this 50 kilohertz probably from the power supply that's feeding the LED. We have all of these. We have the noise from the grid. In the UK, it's 50 hertz. And then we have all of these. But literally any other cable, even BNC to BNC, any other cable, the level of this introduced noise, it can be just contributed to how I place the LED on top and how long I took the averages. But literally, there's no differences between these measurements at all. So just to conclude this video, I'm gonna put this one in the shot because why not? Everybody loves cats. As long as using anything apart from this is a typical speaker cable, and this will take in noise from everything. But as long as you're using anything that is coax and that is shielded, is going to do the job. Again, argument could be made that my cables are too short to notice any differences. And yes, that could be the truth. If you would have a 5-meter long cable, maybe there would be a bit more inductance or capacitance in the cable. But for short runs, if you have a short run from the DSP to the amplifier, you have absolutely nothing to worry about, and you can have a cable as cheap as this oxidized one. It doesn't introduce any distortion. The only thing is that it can lose connection. That's the only thing. Like, even this cable measures frequency response and distortion exactly the same as this one, which is the silver. And again, I'm not gonna argue about the audibility of how the sound changes, because this video again is all about objective measurements, and I didn't see absolutely no differences between any of the cables, again, apart from introduced noise to this cable because it's purely not shielded. So I know that the comment section of this video is gonna be a war zone and a minefield, so I'm gonna be ready for that. But anyway, thank you very much for watching, guys, and I will see you in the next one.